Hello, Paul and the community of developers. Happy to see you again. This is Xavier for the solution of the Arduino challenge about modelizing analog multimeter. So for the multimeter, I took this multimeter, which is a Triumph made in Chicago back in the 50s. Still working, by the way. This will be my model. And so let's go. Or maybe I will show you first my result. Up. Here. Okay. This is a modelization I made. You see with the glass, which is a little bit yellowish, and I put a texture on the casing. The casing uses some kind of gripping paint. I don't know the term for this. This is a metal box with a special paint on it, so it doesn't slip in your hands. It's all metallic. And yes, it's connected to Arduino. If I change voltage, yes, it reacts. Okay. Oh. And we can zoom, of course. Yes, here. And the needle is between the dial and the glass. So everything is respected. Maybe the proportions are not exact, but it's a beta version. Okay, so this is the code here. I started from your version to avoid going too far away from what we do with my previous version. So in the beginning there is no modification. This is what I did here. So the dial is basically the same dial as yours. Then I make the glass. The glass is a box with a color yellow. I put it just in front of the dial, with a little space for the needle, of course. And this is the position vector, and I set the opacity to 0.5. Roundness here doesn't matter. It was just a test for something else, but we don't need it. Then you see in the dial we have a cover here, the black cover, which is this one. This one is a little bit more difficult to do because it's a shape with an inner shape that has to be extracted to make the extrusion. So I call it a differential extrusion here. So to make this, we define here the inner part of it, which will be the shape of the half circle dial. This is the inner shape, and the outer shape here I call the cover out, which is the rectangle. And for the rectangle, here the roundness is useful. It allows us to define rounded corners for the border, which you can see here. Those are the rounded corners. So once we have the both paths here, we can both forms we can extract following the path here, which will be a vertical extraction. extrusion, sorry, which we do here using an array of shapes, which may make the exclusion of the inner shape. Hope it makes sense. Okay, then we can do the metallic cover. This is the metallic cover here that we can see. Oh, I forgot. No, I forgot nothing. Metallic cover. Yeah, I call it the main case cover, which is a box the size of the main box. I just add a texture which is metallic, sort of metallic. Those are the basic structures that are provided. So that gives this grayish metallic cover here for the black box. Okay, nothing special here. Yeah, so a little bit difficult here. There is no specific system for truncated cones. So to make a truncated cone, to make the central knob, I used here a trapezoid, and I made a revolution, which is an extrusion following a circle here. And I rotated the result to make it at the right axis. That gives me that central knob here. Okay, then I have to make all the plugs. I'll show you on the real thing here. So all the plugs here. I didn't make all the labels, but I just made one plug and then inserted it in the face here. So one plug is again an extraction or an extrusion between the outer circle of the plug and the inner circle of the plug. And for each position we will define a path, plug path, and extrude it to the position in black. So here I do at the same loop here the upper row, yes, the upper row and the lower row, which will make those two rows here, and then I make another loop for those two columns here. That's what I do here, vertical, which I call vertical plugs. And then I just put the text here, the label. Okay, and that's it. What do you think? I learned a lot from the documentation. Your indications and the documentation. Now I'm not completely at ease, but it's getting better. Thank you for watching. Bye. See you later.